Use the chain rule of trigonometric functions. So in this video, we are obviously going to use the chain rule and see how we can apply it with trig functions. Alright, so let's take a look at our first example. So in this example, we're being asked to find the derivative of y equals cosine of 4x. And cosine of 4x is a composite function because we have the function of 4x inside of the function of cosine of x. So therefore, this function does require the chain rule to take the derivative. So what does the chain rule say? Well, chain rule says we take the derivative of the outer function first. And as we can see here, the outside function is cosine, and the derivative of that will be negative sine. Chain rule says we leave the inside alone, and then we multiply by the derivative of the inside. Well, since the inside function is 4x, the derivative of 4x is going to be 4. And then all that's left to do is to simplify. So negative sine of 4x times 4 is going to simplify to be negative 4 sine of 4x. And there we have our derivative. All right, our next example, we're trying to find the derivative of y equals tangent of x plus 1. And for this function, it's a little more obvious that this is a composite function because we can see x plus 1 is the function on the inside, and tangent is the function on the outside, which again requires the chain rule. Chain rule says take the derivative of the outside, we leave the inside alone. So the derivative of tangent is secant squared of the inside, and again we throw the inside back in there. And then chain rule says we multiply by the derivative of the inside. Well, the derivative of x plus 1 is just going to be 1, because the derivative of x is 1, the derivative of 1 is 0, and 1 plus 0 is 1. So that means we can now multiply these two things together, and anything times 1 is itself. So we're going to end up with, that is some bad handwriting there. Let me fix that. So the derivative ends up being secant squared of x plus 1. And this is one of those kind of trap examples right here because it looks like we just took the derivative of the outside and we left the derivative alone. It just so happens that the derivative of the inside here is 1, so that's why it appears to be that way. But we need to remember, it is not. All right, our next function is y is equal to secant of 3x squared plus 1. Now this one's going to be a little bit trickier than before. And let's talk about why. Let's just do a little side work over here. So we know that the derivative of secant of x is going to be secant, what's with that writing? Come on. Is going to be secant of x times tangent of x. Meaning that we change from having one trig function into having two trig functions, and we carry the inside into both of those trig functions. So that we're going to need to keep that in mind here, because that's going to be super important, and it's a mistake that is commonly made. Alright, so let's see, the derivative of y, let's just use some different notation here. Let's use dy over dx is equal to. Well, in this question, it's pretty easy to see that the inner function is 3x squared plus 1, and we've already talked about the outer function being secant. So, the derivative of secant, as we said, is secant of the inside times tangent of the inside. And now we need to put the 3x squared plus 1 in both of these trig functions. And again, that is a mistake that is commonly made. Folks just sometimes like just to put x in there and forget about the inside entirely. All right, we've only done half the chain rule because we have only taken the derivative of the outside. So then we need to multiply by the derivative of the inside. And the derivative of 3x squared is going to be 6x, and the derivative of 1 is 0. And then we can just simplify this, and really the only thing we can do to simplify is move the 6x to be in the front. So we are going to get 6x times secant of 3x squared plus 1 times tangent of 3x squared plus 1. And there is our derivative. All right, so now here we want to find the derivative of y equals sine cubed of x. And this one does tend to give some students the problem or tend to give students some problems the first time they do it. Because if we just quickly glance at it, it looks like this 3 is on the inside. But remember, based on our notation from pre-calculus, we know it's not, because we can rewrite this to be the quantity sine of x cubed. So whenever we have trig functions with powers, it's sometimes better to rewrite them so that it's more obvious that the inside is going to be sine of x, the outside is going to be to the third power, or cubed. So again, this is a common trap, so let's not fall into it. So let's go ahead and let's take the derivative. So we're going to have, let's use the dy over dx notation again. So, chain rule says we've got to take the derivative of the outside function, which is the cubed part. So, to take the derivative of the cubed part, we're going to take the exponent, we're going to multiply it to the coefficient, and subtract 1 because it's just the power rule. So that's going to leave us with 3 times the quantity of the inside squared. Chain rule says we put the inside back on the inside, and then we have to multiply it by the derivative of the inside, and the derivative of sine is cosine. And then we'll do our best to simplify, which there's not a whole lot of simplification we can do here. We can just rewrite the sine squared as being sine squared of x, and then times cosine of x. So therefore, the derivative of sine cubed of x ends up being 3 sine squared of x times cosine of x. And then our last example. So here not only do we have a squared, but we also have the dreaded cosecant function. And it's just dreaded because it's awkward. It's only a trig function without a vowel. Would it be different, cosecant? Gosh. Alright, but just like with sine squared, we're going to want to rewrite this. And again, here's another trap. Some folks see the squared and like, oh, we're just going to do the whole 4 cosecant of x, and that entire thing is squared. And that would be incorrect. Because again, it's not the 4 that's squared, it's just the cosecant. So we would have the 4 still on the outside times the cosecant of x squared. And then when it's in this form, we can see the inside is cosecant of x, and the outside is the 4 times the inside raised to the second power. All right, let's go back to our y prime notation, because, well, why not? Now, chain rule says we have to take the derivative of the outside first, which means we're going to take the 2, multiply it to the 4, and subtract 1 to give us 8 times the quantity raised to the first power. Chain rule says we then put the inside back on the inside, untouched, and then we multiply by the derivative of the inside, and the derivative of cosecant is negative cosecant of x times cotangent of x. Alright, so let's get to simplifying. So let's see. Anything to the first power is just going to be to the first power. So we're going to have 8 times cosecant of x. We do have this negative here. So I'm going to bring that negative to the front of 8. And I'm just going to bring down the cosecant of x, cotangent of x. Well, hopefully we see that we have a cosecant times a cosecant, which means we can multiply them together to end up with a simplified version of negative 8 times cosecant squared of x times cotangent of x. And there is our derivative. Alright folks, and that is it for using the chain rule with trigonometric functions.